Okay. Hello. I think I have sent some resources in the chat with a link to the files that you'll have to download for this workshop, and also a, a link to CoCalc.com, which is where we will be doing the activities for this workshop. Okay. I am Emre Yavuz, and this workshop will focus on the visualization of data using Python, and to the extent of what it shows us. So the COVID data we use is collected by various research organizations, and when collecting data, one should always question the reliability of the data. So the data we will be using is from Johns Hopkins University, and let me show the site. So here, this is their main page, and we get the data from their GitHub repository, and and if you scroll down, you can see the government sources that you used to collect it. Okay. So you're going to want to go to CoCalc.com. I'm pretty sure I sent a link in the chat to it. Okay. And you're going to want to download this covid.zip file. Once you do that, you're going to want to find it and then go to CoCalc. I already have it in, but you're going to want to click this upload button and then find the file location. And once you have it, it'll show around here. And then in this terminal command prompt, you're going to want to type in unzip covid.zip. So this is kind of what it looks like. I'm going to wait for people to get to this point. Also, when you get into the CoCalc website, it will greet you with this welcome to CoCalc.ipymb. You can close that. If you have any questions, you can ask them. Okay.
Can everyone give a thumbs up to let us know if you've made it to this step?
Okay. Someone asks, what do I do after going to the website? Okay. So if you have your covid.zip file downloaded, you're going to want to go to the top right corner, and there should be an upload option. And there you should find that covid.zip and upload it. Once you're done with that, you can go to the terminal command right above it and type in this unzip covid.zip, and you should see the files open up below. thumbs up if you made it to this step. Okay. Okay, so the files, I'm gonna wait a bit more.
Emery, we got to keep moving along.
Okay.
So even if not everybody completes every step, I still want them to have the idea of how to do it.
Okay. So the files we're gonna use are this hello world.ipynb and the data analysis.ipynb. And if you open them, you can see it at the top and you can switch between them. So this hello world.ipynb is where we're gonna type most of the exercises, and this data analysis has pre-written code of everything that I will try to cover in this workshop. So yeah. So when you open the hello world.ipynb, it will say print hello world, and it's wrong. So you're gonna wanna put in an end quote, and then to run this, you click Shift Enter. So Jupyter Notebooks allows you to create documents where you can run Python code in cells. So right here is a cell, and when I run this, it shows the execution below. And to run it, you have to do Shift Enter. Okay. I think I'm going to start the next step. So first I'm going to import pandas as PD. And pandas is a Python data analysis library tool. It can read CSV data into a data frame that you can work on in Python. And that's what we're going to do. So I'm going to make a new data frame, and I'm going to call this one df country. And then we're going to get a CSV file from the zip that we downloaded and hopefully unzipped. And to do that, we do pd.read underscore CSV, and then the name, and then we have to give a name, which is cases country.csv. So we created the new we create the new data table, and to show it, we do df, which stands for data frame, if you're wondering, country.head, like this. So, and make sure to click Shift Enter to run it. So what .head does is it shows the top 5 things in our CSV file and the data frame. And we can, if we wanted, we can put 10 in here and show the top 9 or the top 10. Yeah. If you have any questions, you can ask them. Okay. Right now we have this table, but right now it's in alphabetical order, and that's not very useful to us. What if I want to see the country with the most deaths? So to do that, we can do df. We can make a new data frame called that I'm going to call deaths sorted. And make sure you can see it. And make that equal to df country. And to sort it, you do dot sort values, and we're going to sort it by the deaths column. And then if we type in ascending equals false, we'll make sure that it's from greatest to lowest. And then we can show df deaths sorted dot head to show this new data frame that we made. So now we see that the US has the most deaths. And in this form, this table is kind of hard to read. We don't know what it's sorting by. So to make it more clear, we can style it by adding a background gradient. So dot style dot background gradient. And to choose a color, you do color map or CMap equals, I'm going to choose red, and to do that, the reds, but you can also add blues, greens, and more colors. I'm going to quickly show you a website which shows a few of those colors that you can choose quickly. So here's some. Okay, I hope that was enough time. And from here, we can we need to specify what we're applying this to. So we're going to do subset. I'm going to apply it to deaths. And I can also apply it to another or multiple. So I'm also going to assign it to mortality rate. And uh-oh. Okay, there we go. So we can see, I'm going to show 10. So now we can clearly see what this table is trying to emphasize. And that is the US has the most deaths. But the US is actually pretty low on the mortality rate. And this could be because the US has a high population, which means that that is making it so it looks like it has a high death rate. And we can take a better look at this by making a table that shows the deaths per population. Now, I don't know if we have enough time to type it out manually, so I'm going to quickly go over in the second file that we opened, the data analysis one. And if you go over to this fifth cell, you can see it at this corner. And go up here and do run all above. We can see that there's that you can make a data frame that adds deaths per 1 million population to it. And we did that by uploading a separate CSV file and then merging it with this one that we already had, and then using this insert function to add it to create this new row. And we can see that the countries with the highest deaths per 1 million population are these ones here. And this could be because of a low population in these areas, which distorts the denominator, or also due to a high population density in the area, which increases the exposure. Okay. Now, okay, let's go back to the Hello World file and start another activity. In a new cell, we can also show the show this data in a scatter plot, and we can do that using a module called Plotly. So we can import plotly.express as px, and to use it, I'm going to make a new scatter plot. I'm going to call it fig, and that is, and to do it, you do px.scatter, and then we're going to use the data frame df death sorted, and then we're going to do iloc, which all this iloc is doing is we're going to pick the first 10 rows by doing range 0 to 10. And then we're going to specify what's going to be in the x-axis. So for this, I'm going to be doing country region. But you can put anything, any column from here into there if you wanted to. And then for the y-axis, I'm going to do deaths. And then the bubble size is going to be proportional to the deaths. So size equals deaths. And then so the bubbles don't get too big, size max equals 60. And the color will be assigned to each individual country region. So if we do fig.show, okay. Oh, I named this wrong. You should get that load viewer icon, and now we can see this plot. So the bubble size is bigger at this size because that's what we set to, and it looks like it worked because the US has the highest amount of deaths. So this is just another way we can show this data. Okay. If you have any questions, you can ask them now before I go on to the next thing.
We only have 10 more minutes, so
Okay.
go.
Okay. Okay. I am going to go to this, back to this data analysis file up here, so I can quickly go through this. So I'm going to go to cell and do run all. And here we use here we are comparing the confirmed cases of different countries, and we see, and for demonstration purposes, I'm going to set this, not this, this log y to false. So now it's just a normal graph of the data, and we see that the US has a lot more confirmed cases, so its exponential function is distorting the graph. And what we can do is turn this true, so we can use a logarithmic scale for the y-axis to see this. Now we see that the slope of the logarithmic plot is the infection rate, and as we can see, this infection rate has started to flatten in most countries. However, if we look at it, countries like Brazil, Russia, and India are slowly increasing upward. So it may not make sense for them to open up so early, as their slopes still seem to be curving up. Okay. Let's move on to the next part. Here, we're trying to find the exponential fit for the United States COVID data in the early 30 days. And to do that, we need this NumPy module, matplotlib. So this NumPy is going to use for mathematical calculations, and this matplotlib is going to plot the data. So, and to do that, it needs this x and y. And first, to plot this data for the US, we need to find what values we're going to use. And earlier, for this, I imported another CSV file for this to use, and it shows the daily increase of confirmed cases. And to get those values, we can set this y to a list of this confirmed sorted, and choose the rows between the columns between the 40th and 70 days. And at day 40, there are only 60 confirmed cases, which is where we're starting. And then at day 70, it ends up being 140,000. So we can assume that maybe the growth of these confirmed cases are exponential. So that's why we're going to try to fit this and see what this leads us to. So we have the y. So to get the x, we need to just get the length of that y, but this range length y will make a list counting from 0 to 30 or to 40. However, to 30, which is the length of how many days that we're plotting this for. Now, to make this, so here is what is graphed at the end. And this blue line is the actual data. And to get this exponential fit, which is this orange line, you can do this. So this SciPy that we imported has this curve fit function, which gives two variables, this m and k. The m is what we're going to use, which holds the a and b, and the k holds the standard deviation, but we're not going to use that. And it gets this from this lambda function, which this is the a times e to the bt, where t is time and b is the rate. And it uses the xy lists that we made earlier to find what a and b values to fit for. And that is under m. And to get those, we set this a to m0. So m is a list that holds two values. That the a value in this exponential formula is m0, and we set this b to m1. And to plot this, we need to do the same thing as before. So we have to get a new y. And to do that, you just get the same formula and put these A and B values in that we just got. And then this, and since and this makes a list of the new values that will be plotted. So you do plt.plot x, which would be the same because it's the same amount of days, and then y x exp, which is what I named it, as the new y, and then we just get this. Now, if you have questions, you can ask them. Okay. So.
Hey, Emery?
Yeah?
Ethan had a question asking if you have any other resources that you recommend.
I can share that later. For now, I've just been using this Johns Hopkins University. So
I just posted like the Wired article that teaches you how to do the spread of COVID and some other ones from Mark in the chat.
Okay. Well.
So make sure
yeah.
that there are definitely different tools that you can look up to create your database, and Emery showed a great one today. And another big focus that we should have is making sure we're consulting all the information that's available to us. It's like looking at the articles that Julie just sent, or consulting with all of the official databases that are out there in order to get our information and see what the numbers mean for ourselves.
Okay.
I think Johns Hopkins is one of the most reliable and well-regarded, but a lot of times you'll see in the news that they're using numbers that they kind of just made up. So it's really important that Emery is helping us access the data directly.
Okay. How much time do we have left?
4 minutes.
4 minutes.
4 minutes. Okay. I'm going to try to wrap up. So if we were to continue, if I had time to continue, I would try to see, try to extend this growth another 10 days. And when we do that, using this, we find that this initial fitted exponential growth there ends up being a lot higher than what it becomes. And by doing outside data, we find that around day 25 is when we start doing the quarantine efforts. So efforts like that help a lot, because otherwise confirmed cases would be way higher. Now, before we end, I know we didn't have time to go over everything very detailed. So you have this data analysis file that has everything, and I prepared it so it has a lot of comments to help you recreate all of these whenever you want, using your own data even. So you can basically play around with this on your own free time. Also, this summer, we will have workshops starting next week, and July 18th, I will be recreating this, and hopefully we'll have time to go over more stuff. Okay.
Yeah, so, yeah, I was gonna show this at the end too. So,
okay.
if you, if you enjoy this workshop or want to learn a little bit more, or if you're interested in other activities, we've created this series of new workshops that are going to be offered online. And if you want to explore this some more, come July 18th to our data analysis with Python workshop. Yeah, I'll repeat the same information after everyone comes back for the closing. So yeah.